So this is the promise you sent, right?
Yes, sir. Around 15 to 20.
Okay, we'll start with this one because I don't know which order I have.
Okay.
So this one we could
Okay.
solve.
No, sir.
K1 and K2, right? The thermal conductivity of the puncture rod will be. Okay. So what is the direction of the flow of what? What is going to flow? Flow of heat, right?
Yes, sir, but they didn't give the temperature.
Okay. A and B. Okay. The question, I don't think it is specific. There are two ways the heat can flow. One, it can flow like this. This one. Just a minute. Oof. That's, oh, sorry. I'm studying somewhere else. Okay, one thing is the heat can flow like this. So one thing is the heat can flow like this way, or it can flow this way. Okay, and it will come out this way. So let me try both of them. Okay, so you know the correct answer.
Yes, sir.
So what is the expression for heat current? Heat current is proportional to
KA by L.
just a minute. My pen is not working. Hold on. So the heat current H equal to K into temperature difference. Okay, and what's the different area? The area is more, heat is more, right? This is the expression.
Yes, sir. By L.
Yes. Okay, so let me assume that the heat is flowing the direction top to bottom. Okay, so when it's flowing from top to bottom, like this. Okay, so whatever heat is flowing through A is the same heat current that's flowing through B. So H1 equal to H2, right? So if you put H1 for the first one, the area is also same. So it will be delta T1 corresponding to the first one, and assume length also looks same. We have not given, so we can assume it is same, and it's equal to K1, right? That should be equal to K2 A delta T2 by L. Okay, and let the temperatures be T1, T2, T3. This heat should be equal to some K effective into A into this temperature difference is T1 minus T3 divided by 2A. Are you getting it? H1 is the heat current. H1 is this heat current passing through this one. So that is K A delta T by L, right? Using these 2 points, the temperature difference with these 2 points is say delta T1. Okay, this is this conductivity between these 2 points, that is K1. Area is A by L. And similarly, the heat current between these 2 points, okay, temperature difference is say delta T2. So it's K2A delta T2 by L. And if you consider these 2 points, there will be some K effective. Area is same. The temperature difference is T1 minus T3, and the length is 2F. So from this, what we can do is we can get delta T1 and delta T2, and if I add them, T2 will knock out and get the relation between. I think you got the answer now. So what is the answer? Are you understanding?
I don't.
Your voice is breaking.
From these equations, how did you get it? Final thermoconductivity.
Final time I consider these 2 points, this point and this point. Okay, the heat current between these 2 points is the temperature difference between these 2 points, that is T1 minus T3. Okay, and there is some K effective. Okay, and the area is same A, and the length is 2L. Okay, so from this first one, you get delta T1.
The area is doubled now, sir, for K effective.
No, area is same, length is doubling.
Area of the both the rods we have to take now, sir.
The direction of flow is from top to bottom, not left to right. So that's why I said there is a confusion in this question. I'm assuming it's top to bottom, and I'll get the answer. If it's from left to right, it's simple. It's K1 plus K2.
That's what I'm doing.
From left to right, it will be simple. It will be K1 plus K2. So I'm assuming it's top to bottom.
Okay, how did you get it as K1 plus K2 by 2? That's what I'm doing.
Hold on. So for the first one, my pen is not visible. Delta T1 is something is happening. Okay, delta T1 is T1 minus T2 equal to L by K1 1 by A into H. Okay, so similarly, there is no pen. Similarly, T2 minus T3 is L by K2 and then 1 by A into 1 by H. So if I add these two, I'll get T1 minus T3 equal to L H by A into 1 by K1 plus 1 by K2. Okay, so from this you'll get 1 by K 2 by K effective is 1 by K1 plus K2.
Then you get the answer as 1 by K1 plus 1 by K2 on answer, but they have given us what? K1 plus K2 by 2 answer.
Okay. Okay, let me check the answer with this one. It's K effective by 2. Oh my god. Just a minute. So T1 minus T3 is 2L by 2 by K effective. So from this we get K effective as 2 times K1 K2 by K1. This is the answer. The mic is off.
No, sir.
K1 K2. Okay, then we have to assume it's from left to right. So from left to right means H1 is H1 is K1 E delta T by L. Okay, and H2 is KTA delta T by L, and H is H1 plus H2, that is K effective into 2A in delta T by L. So if you put for H1 and H2, so A delta T by L will cancel, so it will be K1 plus K2 equal to 2 times K effective. So K1, so option D. Is it clear? Is it clear?
I can't understand.
The voice is not clear.
Can't understand, sir.
No, this is clear. No, H1.
That is fine. Then how did you equate that actually equal that one?
No, okay, this is clear. H1 is clear. H2
Is fine.
and H is H1 plus H2, because if you consider this whole thing as one composite thing, the total heat that is entering from left to right is H1 plus H2, right? Your mic is off. Okay, so the total heat that's entering from the left side is H1 plus H2, right? Because H1 is from A and the amount of heat entering to B is H2. So the total heat which is entering this composite thing from the left is H1 plus H2. Is that clear? Yes?
Okay.
So that is some K effective into the area area is 2A of the composite. The length is same L. The temperature difference is also same. So in this, if you substitute H1 and H2 from this one, so the terms which are common is A into delta T by L. Okay, that will cancel. So you have K1 plus K2 equal to 2 times K factor. Got it? Speak loudly.
Concept alone, I don't get it, sir.
No, what will this step is clear? H equal to H1 plus H2.
No.
H is the total heat is sent in the left side. What is the heat they're sending the left side? This, on this left side of the composite, it is the heat that's sending through this one A plus the heat that's sending to B, right?
H1 plus H2.
Yeah. So I have to get what is H1 plus H2. So total heat is H1 plus H2, which is entering the left side. That will be equal to some K effective, that's of the composite, into the area of the composite is how much? 2A, right?
Okay.
This area is A. Okay, and this area is also A. So the total area of the composite is 2A. Okay, and the temperature difference is same, left to right. And the length is also same. Okay, so in this expression,
So why would all of them have
Why
same
would?
temperature? All of them have same temperature difference.
because the temperature difference is left side and right side, no? H1 is between these 2 points. H2 is between these 2 points. Okay, it's the same temperature difference, right?
Both the ends are at different temperature, no, sir.
No. This
A
goes
and B.
A, there is A is like this material. This interface is one temperature, this interface. And this right interface is one full, one complete temperature, same temperature.
Okay, fine.
Okay, so the temperature difference is driving H1 is same, but through different material. And the temperature difference is driving H2 is same, but through the different material. So this is the expression for H1 and H2. Okay, so what is it? So this is the case when the thing is flowing from left to right. From top to bottom, what is common is H is common, but what is getting added is L. Okay, so this is the way to, or we can say the total temperature difference will be by adding the individual temperature differences. See the
So
analog
from
is
top to bottom also 2A, no, sir.
which one?
For effective heat current.
The way I did the first one.
H effective equal to K effective into 2A, no, sir. It has to go
No, the heat flowing from top to bottom or left to right.
top to bottom.
Top to bottom is the same area, right? The area here is same. The area here is same. The area here is same.
Two area of the rod.
No. The area through which the heat is flowing is the same, right? The same area here, same area here. So when you have a current carrying wire, the area of cross section area is same, right? Okay, so the resistance which is contributed, the area which is contributing the resistance is this area, but the length will get added. Okay, but when the thing is going from left to right, the length is constant, but the area will get added. Top to bottom, the length will get added. From left to right, the area will get added. Okay, let me give the analogous situation, electrical situation. So you have two resistances like this. Okay, so the potential difference that is driving this current in these two is same. And what is getting added is, say this is I1, this is I2, and this is I. So I equal to I1 plus I2. Okay. So similarly here, when thing is going left to right, the heat current is going to the upper one is H1, the B is H2. So the total heat current which is passing the left face is H1 plus H2. Okay, here the two resistors are in parallel. Okay, so when resistors are in parallel, the resistors will get added as a reciprocal, but conductivity will get added as a sum. Okay, like capacitors. So it is like a capacitors in parallel. When capacitors in parallel means capacitors get added. But since here we are finding specific capacitance, so it's K1 plus K2 and by 2. But this is the basic step or the basic concept. Important thing is you have to figure out what will get added. Here length is getting added, but you have to eliminate T2 because the K effective is involving T1 and T3. So delta T1 is this one, delta T2 is this one. So from this I can get, if I add these two, I'll eliminate T2. This is a standard technique. It's not a, so once you do it, you can do it. It has come in 2017. So by now it is standard, so you should know how to do it. Like when the resistors are in series, what is getting added is potential difference. When resistors are in parallel, what is getting added is current. Here current is getting added. But suppose if you have two resistors in series, so the potential difference across the first one is say V1. The potential difference of the second one is say V2. And if you look at the effective and say the potential difference is V, so this V is V1 plus V2. Okay. In the thermal case, what is driving the heat current is the temperature difference. The temperature difference of the composite is delta T1 plus delta T. That's what I done here. Delta T1 is T1 minus T2, and delta T2 is T2 minus T3. So if I add these two, I'll get the total temperature difference T1 minus T3. Is it clear? For the heat, for the electrical current, what is driving the current is the potential difference. Here is the potential difference is the temperature difference that is driving the heat current. Okay. You can revise it after the class. This is a basic concept. Okay, this one, the value of is also 2015. So fraction changes. Okay, you have to density at basically you have this no the temperature volume at higher temperature is V1 into 1 plus gamma delta T. This is right.
Yes, sir.
Coefficient of volume mismatch. So density will go the other way around. It will be like rho 2 equal to rho 1 plus gamma delta T. Okay. So the coefficient of volume expansion that is gamma. Gamma is given. Fraction change in density. So it is density will, let's say the temperature has increased. So it's rho 1 minus rho 2. Okay. By rho 1. That's what I will find out. Okay. So rho 1 is rho, right? So from this you'll get rho 1 by rho 2 is 1 plus gamma delta T. So from this you get So from this we'll get ρ1 minus ρ2 by ρ2. ρ1 minus ρ2, so it is numerator minus denominator, so it's gamma delta t divided by ρ2. That is 1. Okay. So gamma is how much? 5 into 10 to minus 4, and temperature difference is 40. So 5 into 4 is 20 into 10 raised to minus 4. So it's 10, 20, 2.0. Is this correct? Check the answer. Your mic is off. Your mic is off.
1 minute.
The answer is correct. Option D.
Yes, sir.
Okay, you understood this one? See,
Yes,
what
sir.
is volume relation is this one, so density reciprocal of it. Okay, and from rho 1 by rho 2 is this one. You know how to get this one, right? This step from here. It's numerator minus denominator by denominator on both the sides. So it's gamma delta t by 1.
That's all.
Yeah. Done?
Yes, sir.
Okay. This one. 2 ends of metal rod are maintained at temperatures. The rate of heat flow is found to be 4 joules per second. Okay. This is also a standard question. See, the analogy is this one. Suppose I have resistance like this. Say the temperature to potential difference is 100 and 110 volts. Some current will flow, right, depending on the resistance value. Okay. And if I change this voltage to say 200 volts and then 210 volts, okay, the current, it depends only on the temperature difference or here the potential difference. So since the temperature difference is same on both the cases, okay, so the heat flow should be same. So it's trivial question. Option B. So in this case, heat current is AA delta T by L, right? So everything is same. So in first case and second case, all these things are same. Even delta T is same. So H1 equal to H2. Done? Check the answer.
But what if they given like 213 like that?
Yeah, suppose this was 220, then what will happen is delta T is different. So H1 is this constant, this factor, okay, that factor into 10, and H2 is the same factor into 20. So H2 is 2 times H1. So then in that case, the answer will be 8. Okay. Got it, no? This is the basic formula. Okay, heat current is this one. So suppose if it is 220, then delta T is different. In the first case, it is 10. In the second case, it is 20. So more heat will flow the second case, and this twice. Is it clear?
How did you say it is 10 and 20?
Delta T is the first case, no? 110 minus 100. In the second case, it is 200 minus 220 or 220 minus 200.
Yes, sir.
Delta T is the temperature difference which is driving the heat current. So delta T in the first case is 10. In the second case, it is increased and it's become 20. So heat current will become twice of the first one.
Okay.
Done?
Yes, sir.
Okay. The slab of stone of area and thickness is exposed on the lower surface to steam. The block of ice rests on the upper surface for 1 hour. Okay, this is a trivial question. Again, the same formula I have to use. So write the situation for, there's only one case, no? Yeah, everything is there. So get the answer. So Q is 4.8 into 18, and the time is you have to do the calculation 1 hour, right? So it is 3,600 seconds. So everything is given. So only K is unknown. Area is known, delta T is known, length is known. So to solve this, I'm not going to do it. Get the answer.
1.24, sir.
Okay, check the answer.
Yes, sir.
Is it correct?
Yes, sir.
Okay, so there are only two steps here. One is this formula, heat current is this one, and after that, H is Q by T. This you understood, right?
Yes, sir.
It's the heat current, so total amount of heat that is being transmitted in 1 hour divided by the time. So the amount of heat that is transferred in 1 hour is the amount of heat that is melted. So there's one more concept here. The amount of heat is the heat that goes in melting it. Okay, so it's 4.8 into the latent heat. So three concepts are there. Clear?
Yes, sir.
Okay. This one, cylindrical metal rod, thermal contact with two reservoirs of heat, and it's another Q, time T, and it is from the wall of arc. So it's a trivial question. It's the same formula. What is the amount of heat conducted by the knee rod placed in thermal contact? So if you draw the picture, then it will be clear. Cylindrical rod. Okay, so in the first case, it's like this. In the second case, the rod is long. That is thinner. Okay. The amount of heat that's flowing is Q, and the time it takes is P. Here the radius has become R by 2. Here the radius is R. So here if you see it is Q2.
4 into length.
and the amount the time
Then
is. So you have to get the expression for heat current. So in the first case, heat current is what? H equal to K A1. Temperature difference is same, right? So it's delta T divided by L1. So this is H1. Similarly H2. K is same because material is same. Delta T is same by L2. Okay. So what is the amount of heat? So you have to find H2 by H1 or H1 by H2 both are same. So if you do H2
16, I guess. So.
by H1, it's A2 by L2 into L1 by E1. Okay. And L1 you do know, right? So another thing is A1 L1 is A2 L2. So multiply numerator and denominator by. So here I multiply by A1, so become A1 square. And here I will multiply by A2, so become A2 square. And A1 L1 and A2 L2 will cancel. Okay, so this ratio of the radii R2 by R1 raised to the power 4. And R2 has decreased. So it's 1 by 2 raised to the power 4. It's 1 by 16. Check the answer.
Yes, sir.
Okay, is it clear?
Yes, sir.
Okay. The first one is like this. Second one, the rod has become thinner. You know why A1 L1 is same as A2 L2?
Yes, sir. Volume conservation.
Yeah, because density is not changing. The density of the material and mass is conserved. So mass is conserved, density is not changing, so volume is conserved. Okay. So done, no?
Yes, sir.
So basically it's the see, the cylindrical rod. Okay, so that's all. The amount of time is same T and the temperature difference is same. Okay. Amount of heat. The temperature difference is same. So you have to find the difference in the heat flow.
Yes, sir.
Okay. This one temperature of a body increase 9 times in time it's how many times the temperature difference in increase in Celsius. Okay, this is also a trivial thing. You are not applying basic concepts. Okay, what is the relation between Fahrenheit and Celsius?
F minus 32 by 9 equal to C by 5.
Same, right?
Yes, sir.
Okay, so if you can put like the F1 corresponding to the first case, so similarly F2.
So 9 by 5 C, sir.
Okay. So now we know how to do, right? If you subtract these two, you get F1 minus F2 equal to 9 by 5 C1 minus C. Is that clear? So F1 minus F2 is 9, so it will be 5. Answer is 5. Check the answer. Is it correct? Is it correct?
Yes, sir. 5.
Okay, understood, right? This is the relation. So if you put the first integer, you get F1 CC1. In the second case, it's some F2 and some C2. And if you separate these two, I'll get F1 minus F2 this one. So the difference in parent scale is what is increases 9 times. Okay, the question is not clear. F2 because of what increases by 9 if it needs it. So that means F2 is 9 times. Or you can say F1 is 9 times F2. So 9 minus 1 is 8. Okay, the question is not written properly. It's not 9 times, it's increased by 9. Okay. It's increased by 9
Yes,
degrees.
sir.
Okay. So similarly, the increase in Celsius will be 5 degrees. Done?
Yes, sir.
Okay. Relation between two states. Okay. At which temperature? It's a trivial question, no? We just have to put A equal to B equal to some K. When the truth.
Sir, but I didn't get the right answer, sir.
So this K minus K minus 42, right? 100 equal to K minus 72 by 220. So 22, 10 will be equal to 20 times 42 minus 720. So what is 22 into 42? Region is 42 is how much? 84, right? So 924. So it's 924 minus 720. So that is 204. Oops, correct me. So 204 by 12. So we do 12. 1 sub 84 to 17. What answer you got? I'm getting 17. 10 times is 120. Getting 17. Okay, what is the answer they are given?
Plus 12 degrees Celsius, sir.
Plus 12. So you put plus 2 in this thing. So 12 minus 42 is how much? 30, right?
12 minus
30.
Yes, sir.
So we check that one. So it is 30 by 100 equal to, so this have to check 12. So it will be 60 by, it's not true. So maybe there is a mistake. This should be 110 then. Instead of 100, it should be 110. Okay. If it is 110 means it will be this will go twice here. So then it become trivial. 2A.
I got 204 degrees Celsius.
No, the answer they are given is also not correct, no?
That's why I sent you.
Okay. Maybe see, is this a Kelvin scale or what? Okay, some scale. Okay, some degrees. Okay. This 204 by 12.
Yes, sir.
Okay, just leave it. It's not a. But the basic concept is you have to put A equal to B equal to K, and then you have to find K. This one Celsius and Fahrenheit temperature of dipped in boiling water. The temperature of water is reduced to 140. What will the increase in gradient of Celsius? The same thing.
But I didn't get it.
You have to use that. From this you get F2 minus F1 is 9 by 5. C2 minus C1. So what is boiling temperature in the Fahrenheit scale? 212. Right?
I got.
What is boiling
Yes,
temperature
sir.
of water of 212 in this one? Right? So it is 212 minus 140 is how much? Now minus 4 is 7. So 72. So this is 72. So 72 to 5 by 9. So 9 8 are 72. So it is 40. Check the answer.
Sir, option B. But I did it like 140 minus 32 by 9 equals 3 by 5.
So this is the only way to do it. F is 9 by 5 C minus this one, right? So from this you get F2 minus F1 equal to 9 by 5 C2 minus C1.
But we got one answer, no, sir, like expression F minus 32 by 9 equal to C by 5. I put the F as 140. I didn't get it. Can see it.
This is the only way to do it. How is F and C related? This relation, right? And there are two cases. So F2 minus F1 is 9 by 5 C2 minus C1. So the temperature difference in Fahrenheit scale is 212 minus 140. So what are the corresponding temperature difference in the Celsius scale? This is the only step you have to follow. Then got it?
Okay.
Relation between 1 degree Celsius and 1 degree Fahrenheit is such a trivial question. You can just use this thing. So when F2 minus F1 is whatever. So basically the 1 degree drop in Fahrenheit will correspond to basically Fahrenheit scale is finer divisions. Celsius scale is a bigger divisions. Fahrenheit scale is finer divisions. So the A is definitely true. C is not true. Okay, then this is the only one.
Yes, sir.
Okay, again the question is not what the question should exactly mean is one temperature difference is 1 degree Celsius and temperature difference is 1 Fahrenheit Celsius. 1 Fahrenheit. Which one is greater? So you can say mass difference of 1 gram and mass difference of 1 kg. Which one is more? 1 kg.
1
right?
kg.
Similarly,
Yes, sir.
see in the Celsius scale between ice and steam point, there are 100 divisions. In Fahrenheit scale, there are how many divisions? 32 and 212, right?
Yes, sir.
It's around 180, right? So Fahrenheit, there are more number of divisions, so it is a one division is smaller,
Yes, sir.
corresponding to an absolute temperature. So Fahrenheit scale is finer scale compared to Celsius scale. So 1 degree Celsius temperature difference is more compared to 1 Fahrenheit. Okay, increasing temperature. Okay, this is a trivial. I mean, you already done it. This one, same relation you have to use. So in Celsius is 925, right? So fan will be 9 by 5 times that one. Number of divisions in fan will be more. So 9 by 5 25 is 9 into 5 is 45. Got it?
Yes, sir.
Actually, again, the question is not. This should be thermal conductivity. So you have to go to the basic then. Thermal conductivity. Suppose if we take this one as so it will come out to be alpha delta T here. So alpha F into 1. Okay, this is I'll come back to this later. So these are the questions, right? I don't think it said anything more. So it's done. I don't think you have sent any other question.
I done with 15 questions, sir.
Okay. How many are here? I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4 are missing. Okay, I'll do it next time because I have to copy from WhatsApp, right?
And problems I gave you now.
Triple bond is
On March 14.
it's not there in syllabus.
March 14. No, sir, that is NCRT problems only.
No, the triple point, which one? The one you sent right now. Triple point is not there in syllabus. Which date?
1 minute, sir. 5 problems. No.
Okay, we'll look at these things later because I hope.
Last question, sir, is not related to this.
No, last question is complicated. Leave it because it's not clear. I'll get back to that later.
Okay.
We'll pick up some questions from this one previous year. Have you already done these things? We have not done these things, no?
Okay. Things are thermodynamics.
2019. Try this one gram of water of volume that is converted to steam, same temperature. The volume of steam is specific. So you're following this one. So there is change in volume, no? When it was water, it is 1 centimeter cube, and volume has increased to 1671. So the increase in volume is 1 centimeter cube. Okay. 671. Okay, it's converted to meter cube. Okay, pressure is this one. And atmospheric pressure. So you're using this first law of thermodynamics. So this is the important step. Delta U plus delta W. This is first of thermodynamics. And you know delta W because it's P into dV. Sorry, P into delta V. The delta V is the increase in volume. Pressure is the atmospheric pressure. 1 into 10 to 5.
Yes, sir.
Okay, so delta W is P into delta V. Pressure is known, delta V is known. So delta W is known. Delta P is the amount of heat that is supplied. And the heat has got into changing this water into steam. So it is mass into latent heat of vaporization. So delta Q is also known. From there you can find delta U. So delta Q is mass into latent heat. So mass is 1 gram and latent heat is per gram. So it's simple. This one. So you know delta Q and delta V is known in meter cube and pressure is known. Okay. If you put everything, you will get the answer. Delta W is P into delta V. The important thing is the one volume volume has changed from 1 centimeter cube to there is only one small trick in this question. See, if it is a gas of 1 centimeter cube, which is going to expand into the final volume, and the work done is P into delta V. But here it is initially it's 1 centimeter cube of water, which is getting converted to gas of or steam of final volume. Again, the work done is P into delta V. That is not very clear. So it's basically assume okay. So because the work done P to delta V is gas going from one state to another state, but here it is thing changing from liquid to gas. That
Yes,
is
sir.
that's a tricky part. Okay, which I don't understand fully. I don't know. It's true. This one is sample of It's the same question. Exactly same.
Didn't give the initial volume.
It's for 0.1 gram at this thing, right? So, you know the density of water. So water usually have 1 gram will occupy 1 cc. So
1
0.1
ml.
1 cc, 1 centimeter cube. So 0.1 gram will occupy 0.1 centimeter cube.
Okay, fine. So, but these sort of things we can't do in a single minute, no, sir. It will take more time.
No, once you if the same question comes in exam, you should be able to do quickly because they have repeated. No, it's coming in 2019 and 2018. Same thing. Delta Q is mass into latent heat, and the pressure is atmospheric pressure. So delta V is this one, and volume of water is 0.1 cc. That's what they put. Is it clear? Volume is 0.1 cc, initial volume. We move to the next one. During isothermal expansion. Okay, this is also a simple question only. So what does this mean? Isothermal expansion, gas does -1 joules of work against its surroundings. This equals the 300 joules must be added. Okay. When they say the work, gas does this much of work, right? And they are given minus. So that means work is done on the gas, not by the gas. Because work done by the gas is negative. So that means that work is done on the gas.
Here they are given negative volume.
No, that's the meaning of negative. I'm saying, okay, let me check it. Isothermal expansion temperature is not changing. So isothermal expansion means delta U is 0. Delta Q equals delta U. So this is 0. It's expansion, right?
No, work done is negative, it means that
Okay.
no, sir.
Check the option. That's not clear. Let me check the option. Is added to the system. That's not remove it is transferred. Okay, because it is added to the gas. Yeah. So basically, delta Q and delta P delta V, the magnitude should be same. So it's 150 is removed from the gas. So this is less gas less minus 1 joules of. This is actually work done by gas.
Yes, yes.
Okay. So okay, option C. So here it's actually expansion only. Okay, this is actually 150 only. Okay, according to me, this should be plus. Okay, one thing is clear. There's an expansion, right? Okay, that means heat is added to the system. It's isothermal, so delta is 0, and expansion, so heat should be added to the system. So this is the option is added. Okay. And when they're expanding, the gas is the work is done by the gas. The work done by the gas is plus 150. So according to me, this should be only plus 150, not minus. Okay. Done.
First option, sir.
Option B and C versus B and D are wrong. Because for isothermal, delta is 0 and delta W need not be 0. Okay. And adiabatic versus delta Q is 0. So according to that, delta Q equal to delta U plus delta W, first option should be correct. That is A only. Oh, this is a trivial question. Delta Q is Then we're changing the system was absorbed 2 kilocalories. Right? So
7,900 joules, sir.
plus work is done. Okay, the work is done by the thing, right? 500 joules. So you have to convert calories to joules. So, okay. What is the conversion factor? 4.2, right?
0.2.
So it's 8.4 minus 500. 7,900. So D. That is B. Got it? Done, no?
Yes, sir.
Okay, we'll close now.
Okay.
Okay, so tomorrow I'll tell the time. Either 3:30 or 7:30. Okay,
You inform me in the morning itself, sir.
okay. Fine, I'll send a message.
Okay, thank you.
Okay.
Bye.